before we start adding and subtracting when the denominators are not the same, we need to find common denominators, look at how to rewrite a fraction to a different denominator, and then go into actually adding and subtracting. All right. So the first notion is common multiples. And before you can find common multiples, you just have to know how to find multiples of a number. So multiples of a number is what happens when you just keep multiplying using that number. So for example, the multiples of 2 are 2, 4, 6, 8, 10, 12. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And you keep going. Those are multiples. Multiples of 3, 3, 6, 9, 12, 15, 18. Multiples of 6, 6, 12, 18, 24, 30, 36. So as far as multiples go, a common multiple is a number that everything in the group shares. So in this case, notice that 12 shows up in every single column. 6 shows up in every single column. If I were to continue out the 2's, 18 would show up in every single column. So common multiples based off of what we've written would be 6, 12, 18, 24 would have shown up. Keep on going. So there's lots of common multiples. The least common multiple is the smallest of those numbers. The least common multiple is just the smallest. So the least common multiple of 2, 3, 6 is the number 6. Why? It was the first number that matched. First number that matched. So common multiples are all the numbers that match. The least common multiple is the smallest one. So any questions on the difference between the two? Now, when we start adding and subtracting, you don't necessarily need the least common multiple. Most math classes in elementary and middle school tell you you must have the least common multiple. No, you don't. You just need a common number. If it's the smallest one, so be it. But you don't need the smallest one to get it done. So, least common multiple of 4 and 6. Least common multiple of 4 and 6. Any guesses before we work this out? Least common multiple between 4 and 6. 12. So least common multiple of 4 and 6 is 12. So 4 is 4, 8, 12, 16, 20, 6, 6, 12, 18, 24, 30. So 12 is the first number that matched. Now, as soon as you get the first number that matched, stop. So as soon as you got to 12, you didn't have to write 18, 24, or 30 because you got the first number that matched. That's all you need. So the least common multiple is 12. Least common multiple is 12. Let's do another one. Example 3. Least common multiple between 7 and 10. Least common multiple between 7 and 10. So if you list out all the multiples of 7, list out all the multiples of 10, what's the first number that matches? What will be the first matching number? You take a minute, write the multiples out, which is actually what I'll have you do right now. Do that. So take 30 seconds and solve that problem. Recorder back on. So for 7, you have 7, 14, 21, 28, 35, 42. So normally, do the first 6. Do the first 6. See if you get a number. If you don't, you have to keep going. 70. There you go. Least common multiple 7. Least common multiple 7. So the way that this could look on a quiz or a test would be find the least common multiple of 2 and 7. And tell me what it is. Then I might ask you, find another common multiple of 2 and 7 that is not the smallest. So that means you just tell me the next number that works. Tell me the next number that works. So the main reason why we use common multiples is because we have to know how to change a fraction to a different denominator. How do we change a fraction to a different denominator? So let's do that part. How do we change a fraction to a different denominator? Easiest way to do that is through multiplication. The easiest way to do that is through multiplication. So the first problem is asking us, write 5, 6 with a denominator of 18. So when you have 5 over 6, you want to change the denominator to 18. So you can't change the denominator without changing the numerator with it. You can't do one without the other. So most people get this wrong by doing this. Write the fraction 5 over 6 with a denominator of 18. They put 5 over 18. That's 100% wrong. It's not 5 over 18. You can't change the denominator without changing the numerator. But how you do it is very simple. You have 6 and 18. What times 6 gives you 18? 3. 6 times 3 gives you 18. So whatever you do to the bottom, you must do to the top. So if you're going to multiply the bottom by 3, you're going to multiply the top by 3. 5 times 3 is 15. So your new fraction is 15 over 18. What you do to the bottom, you must do to the top. There's no choice in that. There's no option in that. Any questions before we continue? All right, example 2. You have 8 over 9. We need to make the denominator 63. Same process. What times 9 gives you 63? You're going to multiply 9 by something to get 63. Jordan, I see you with the 7. So if you multiply the bottom by 7, you're going to multiply the top by 7. 56 over 63. Again, what you do to the bottom, you do to the top as well. So, go ahead and give the answer. You have 36 over 84. Is anyone willing to co-sign that? All right, so we got someone to co-sign with you, and I'm going to go ahead and verify that. 7 times 12 is 84, so 3 times 12 is 36 over 84. So I agree with your answer. I agree with that answer. Questions before we get into the actual adding and subtracting? So again, this is a basic concept that we need in order to add and subtract correctly. All right, adding and subtracting. So on Monday, we added and subtracted with the denominators being the same. They were already the same, so we didn't have to worry about changing it. Now, we have to worry about changing it. So we need to get the denominators to be the same before we add or subtract them. So here's an example of the work we're about to do. So 1/3 plus 7 over 12. We need the denominators to be the same. We cannot add these the way that they are. So we look at our denominators and we ask ourselves, is there anything times 3 that will give me 12? Or is there anything times 12 that will give me 3? Because I need to make these the same. Since I know 3 times 4 will give me 12, multiply the first fraction by 4. Again, you need the denominators to be the same. Once they're the same, then you can add them up the same way we did on Monday. So sometimes you only have to do one fraction. Sometimes you'll have to touch both fractions. When you have to touch both fractions, then That's what we call forcing the problem to work. So there are times in which we're going to force the problem to work. Yes.
So you don't, so even though you got both denominators to be the same, you don't add them.
We did it. 4 plus 7 is 11.
No, yeah, I know, but like, what about the 12?
You never add the denominators.
Oh,
We didn't do it Monday. We're not going to do it now.
alright.
Once the denominators are the same, you leave the denominator the same. Now, 11 over 24 would be there as what's called a send-off answer. When you have multiple choice problems, which you will on the test that you'll take on next week, there are problems up there, there are answer choices that are send-offs. So beware of the send-off. Questions before we do some examples. 2 adding, 2 subtracting, 2 mixed, and then we'll take a short break. Alright. First 2 are added. So we have 5, 6, and 1, 12. So we're doing 5 over 6 plus 1 over 12. So, the denominators are not the same. Is there anything times 6 that will give you 12? 2. So, we're going to multiply the top fraction by 2. If we multiply the bottom fraction, you're going to make that 24. So that doesn't help you. Once the denominators are the same, then you can go ahead and add. 10 plus 1 is 11. The denominator stays the same. Remember, the denominator does not change. The denominator does not get touched. Once you make it the same, you don't touch them anymore. Question on first example. Alright, so problem 2. 1/8 plus 9 over 12. You have an 8, you have a 12. So, there's nothing times 8 that's going to give you 12. There's nothing times 12 that's going to give you 8. So now we got to find a multiple that they share. Now we're going to find a multiple that they share. So, list out all the multiples of 8, list out all the multiples of 12. What's the first number that they're going to share? 4. So 4 is a factor. Multiples is when you do 8 times 1, 8 times 2, 8 times 3, 8 times 4.
Right.
So 4 is what will divide into them even. You're looking for the first number that they will multiply up to. So think about what we did earlier. So 24, Jordan puts in there And I agree with that.
36.
So 36 works with 12, but it doesn't work with 8.
Oh, my bad.
It's okay. Sorry to make a mistake. So for 8, you have 8,
24.
16, 24, 32, 40. 12 times 1 is 12. 12 times 2 is 24. So 24 wins. So we're going to make both denominators 24. So now, I told you now we have to force the problem to work. Now we're forcing the problem to work. Now we're forcing this problem to work. What times 8 gives you 24? I see there 3. So 1 times 3 is 3. What times 12 gives us 24? 2. Any questions before we continue?
Mr. Long.
Yes.
Once you get your answer, like the final answer, could you reduce it?
Always reduce.
Okay.
So for this problem, we will definitely reduce. 3 plus 8 is 21. So what can I divide this by? 3. You get 7 over 8. That gives you 7 over 8. Question with add. Any questions with add? Let's do it with subtraction. So subtraction works the same way. So 7 over 8 and 5 over 24. So we have an 8, we have a 24. Is there anything times 8 that will give me 24? Anything times 8 that will give me 24? 3. So 7 over 8, we're going to multiply times 3. 21 over 24. Then we solve it out. 21 minus 5 is 16. Is there anything else that we can do to that? Alright, what did you divide by? Alright. Did you just use 8 or did you use a couple of numbers to get there? Okay. That means you're getting better with dividing, reducing fractions, my friend. Alright, so that's example 1. We give give you a minute to start example number 2. So, there's nothing times 5 that gives you 3. There's nothing times 3 that gives you 5. So it's time to start writing multiples. 3 times 1 is 3, 6, 9, 12, 15, 18. Now you start writing your multiples of 5. 5, 10, 15. There's your common multiple. So as you get the first multiple, you stop. So 15 is what you're going to use. Now, 5 times 3 gives you 15. So you're going to do 4 times 3 at the top. 3 times 5 gives you 15. So you're going to do 1 times 5 at the top. Any questions so far, Steve?
No, good.
So now we can subtract. 12 minus 5 is 7 over 15. And 7 over 15 can't be reduced.
So basically, we have two fractions there. Because I didn't actually get to like start trying to understand that little bit. Like what would you get to
Then that means you need to immediately go and start finding multiples.
yeah, I didn't start trying to find multiples until you started writing down the like for some odd reason I didn't start finding multiples. But it's like you like on test when we had a situation like this, we just have to go through multiples.
Yep. So when you practice your homework and when you're doing your study guide, you gotta build that speed and build that endurance. Because remember, you don't want to spend 5 minutes on one problem. You'll run out of time. But before we do problems that look like one from the extra credit from last week, go ahead and take so problems 5 and 6. So 5 and 6 look very similar to one of the 2 problems that was in the extra credit. I'll also tell you how the other extra credit problem was supposed to be done. It asks you to find the sum of the factors of a particular number. So, for example 5, if you have adding and subtracting in the problem at the same time, remember order of operations. So that's add or subtract from left to right. So tomorrow we're going to be getting more into order of operations, but still follow order of operations. So that means 11 over 18 minus 4 over 18 would go first. So 11 minus 4 is 7. 18 wouldn't change. So now we have 7 over 8 plus 1 over 6. The denominators are not the same. So we need to make them the same. So, is there anything times 6 that will give me 18? Anything times 6 that will give me 18? 3. Multiply by 3. That gives you 3 over 18. So 10 over 18, which reduces to 5 over 9. That reduces to 5 over 9. And that's that problem over. Problem 6 works the exact same way, only notice that you don't have common denominators. So you still work from left to right. So you're going to do 2/3 and 3/8. So we leave off the 5/12 for a second. So, Steve, this is similar to that last problem with the multiples. There's nothing times 3 that gives you 8. There's nothing times 8 that gives you 3. So we start doing multiples. Now, the listing out of the multiples, you don't have to list them out unless the problem specifically tells you to. I'm pretty confident some of you can do the multiples in your head. But if you need to write them out for yourself, do that. So, least common multiple is 24. Three times 8 gives you 24. So 8 times 2 is 16. 8 times 3 is 24. 7 times 3 is 21. So now we add them up. 16 plus 21 is 37 over 24. But you still have minus 5/12, so you're not done with the problem. Any questions before we continue? Let's go ahead and finish. Go ahead.
Would you multiply 12 times 2 so you get 24?
Absolutely.
And then also 5 times 2?
Absolutely.
Alright, then.
So
I
that's
got this.
10 over 24. So that's 27 over 24, which you can reduce. That's 9 over 8.
So you end up with an improper fraction of, if you end up with an improper fraction, if it doesn't make sense, it's okay to leave it like that. Like
It's okay to leave it as an improper fraction as long as you reduce it.
Okay. Thank you.
No problem. All right. Any questions before we look at mixed numbers? All right. So mixed numbers. So remember, when you're adding or subtracting mixed numbers, change them to improper fractions first before you start anything. Change them to improper fractions first. Just know that now, since you don't have common denominators, you need to get them before you add or subtract. So, for the two examples that you see here, you would first change them to improper fractions. That's 41 over 9. And then change the denominators so that they're the same. So that would be the setup for that adding problem. your setup for the subtraction problem. So yes, I just did the fast-forwarded version of what we're about to do. So I just did the fast-forwarded version of what we're about to do. Any questions before we do the last set of examples? Finish up here right on time. So let's do this. Alright, so 1 2/5 plus 3 3/10. So the subtraction example is there in case people finish early and want to work ahead. So if you're a person that likes to write it up and down, that's fine. No problem with that. One 2/5. If we make it a improper fraction, what's that?
7/5.
7/5. And 3 3/10 is what?
33/10.
33/10. Some of y'all that's probably light work at this. So the denominators are not the same.
5 times 2, 7 times 10.
He on it, man. I found his groove. All right, superstar, finish it. There we go. 14 and 33. What do we get?
47.
47. So 47/10. Now, this cannot be reduced, so you can leave this as a final answer. If you converted it, it would be 4 7/10. Yes, sure. Again, you do not have to make it a mixed number unless the directions tell you to. You can leave your answer as an improper fraction. Problem 2. Let's do a subtraction problem. Anyone else still need example 1? Anyone still need example 1 before I scroll it up? All right. Example 2. 6 3/4 minus 3 2/5. So first we change everything over. 6 3/4 becomes what?
27/4.
27/4. And 3 2/5 becomes what?
17/5.
17/5. So there's 2 points right there. So that's 2 points. 4 and 5 are not the same denominator. So what denominator is going to work? 20. Nothing times 4 gives me 5. Nothing times 5 gives me 4. That's when you would write out your multiples. So 4 times 5 gives you 20. So you can do 27 times 5, which is 135. 5 times 4 is 20. 17 times 4 is 68. So all we have to do now is just finish it. Uh-huh. Did you list your multiples? Looks like you're still working them out, so it doesn't look like you listed your multiples. Shortcut steps. So you got 135 minus 68, which is 67. 67 over 20. So that can't be reduced. So you can leave it that way, or give it as the mixed number. Questions before we do the last example? Last example of this day. Again, just think to yourself, especially as you prepare for your unit test, the more work the problem takes, the more points the problem is probably worth. The more work the problem takes, the more points it's probably worth. Alright, so we'll finish up with problem 3. So we have 11 minus 6 2/3. What's wrong with that 11? It's just an 11. So we probably need to make this 11 a fraction. How do we make 11 a fraction? Put it over 1. That 6 2/3, we still change to an improper fraction. So that's 20 over 3. So, we still need a common denominator. What times 1 gives me 3? What do I multiply 1 by to get 3? 1 times 3. 33 over 3 minus 20 over 3. So you get 13 over 3. So either leave it that way or change it to a mixed number. And when you do your online quizzes and things of that nature, you have that freedom to leave it as a improper fraction. Any questions adding or subtracting before we close this out?